Welcome to part 2 of my PCG Interiors series. In this episode, we'll cover adding props to our room with various zones for those props to spawn in, as well as covering room types to control what types of props spawn into a particular area. And we'll also add spawn weights so that we can set how likely a prop is to spawn. We'll also set limits to control how many of a particular prop spawn in. My original plan for this episode was to build hallways and connections between the rooms. But unfortunately that didn't work the way I was planning, so I'm covering props and room types in this episode, and then we're going to connect the rooms together in the next episode. For our prop spawns, we want to define a few regions where we want the props to land. We want those on the walls. On the walls is great for paintings, lanterns, cupboards, or anything else that we want on the walls. And then we have a zone that's going to be next to the walls. So this will be good for bookshelves and furniture, which is on the floor, but it needs to be up against the walls. And then we're going to have the center of the room, which is going to be anything else. And once we have these regions defined, you should know the ways to create other regions that you may need. So let's get started. In our PCG room, we pretty much have everything we need. We have our corners here and our centers here. So this is the center of our room. So we can use this to spawn off of for the center items. Off the corners, we built our walls. So this here builds the wall. And we actually want the wall without the doors in them, and this difference right here takes the doors out. So that's great for our spawn, so we'll want to use this point here for walls and our next to the walls. Let's just move this wall mesh out of the way. So then let's turn the debugging on for these wall points, and let's take a look at them. We can see they're all right here along the walls, which is perfect. But for items that we want to spawn on the walls, we obviously want those up higher, so we'll need to adjust those points in the Z direction. So let's use a transform points for that. So let's set this offset in this transform points and figure out where we want this height at. Just guess at like 200, and then we'll turn off this debug and turn this debug on, and I think extents will be good. So those are a little high, and they're sticking through the wall, so they need to be rotated at 0. Oh, I copied them off this one that had a rotate of 90 on them, that's why they were rotated. And then we don't want this offset either. There we go. So now we have a set of points that runs around on the walls, and we can adjust this height later to give us our fit, but this should be good for if we wanted to spawn items and hang them on the walls. It should be about perfect. Okay, so that's our on the wall points. And then let's get next to the wall points. So we'll do the same sort of thing here. But instead of transforming in the Z direction, we're going to want to offset in, I think, the X. And let's move our debug over. Yeah. So there we go. And we're going to want to get rid of these points here, most likely, because there's going to be 2 of them there. That's going to be a mess. So that's a good next to the wall set of points. We just use self-pruning to get rid of those corner points. So that clears those down to just 1, which will be much better. So for figuring out what we want to spawn, we're going to go out here to BP room, and we're going to set up our room types. To create our room types, we'll want to define a data table. Before we can define a data table, we need a structure. So we'll define a blueprint structure. We'll call this S_room types. And then we'll define the data table fields with this structure. So we'll want the room. So this will be the name of the room, like we say we're defining a library or a wizard's study or any type of room that we'd have. And so we're just going to give this a name. Then we want our prop, and I think we want an object type for that, probably an actor. We'll try and do a prop type. And we'll want the region. So for our prop type and our region, I think we want to define an enumerated type for that. So we'll need to create an enumeration. So let's go and create a blueprint enumeration. And we'll have E prop type. And another one, E region. Let's do our region first. That'll be simple. So our regions are on wall, next to wall, and from center. And then our prop types. So I'd like to have a static mesh type. I'd like a blueprint and a PCG type. So like a PCG subgraph, something that's more complicated, like a table and chairs or a bookshelf with extra books on it that you want to create a subgraph for. We'll have a PCG type for that. To finish defining our structure, we want our prop type to be of E prop type, and our region is E region. Save that, and then we should be done with that structure. And then we're going to want to create a data table, which is under miscellaneous data table. This will be, we pick our row structure, so we want S room types, and then this will be DT rooms. So then when you add rows to this, it'll already have this defined structure of our room, which we can give a name. So let's say we're going to have library, and then we'll define our prop types for this library with multiple rows in this data table. And then when we build a library, we can pull all the data from this data table and spawn in these actors. So let's get to work on that. So I'm going to create a new folder in the PCG folder called props, and then I have a bunch of assets I've downloaded from Sketchfab, and I'm just going to import them. I will just show you one asset, and then we'll go from there with your own assets, and we can build this out. There will be a list of assets in the description if you want to get the same assets I'm using. When I'm importing assets in Unreal 5, I like to get the GLB file. The GLB file has all the parts of an asset in one file, which is really nice, makes it easy to import. Whereas if you get a different kind, like this book stand is a GLTF file, then the textures are all separate, and it's just not as compact and easy to import. Importing a GLB is really easy now. Let's do this bookshelf. Just drag it in. And often we want to combine static meshes. Depends on what you're importing, whether you want to combine static meshes or not. If the mesh is supposed to be one thing, then you'll want to combine static meshes. But sometimes, like say this bookshelf has books on it and I want those books to be manipulated separately, I might not want to combine those static meshes so that I have different meshes. But I'm going to combine static meshes for this, see how it goes. All right, so we have our bookshelf here. Let's pull that into the scene. Often items that I pull in from Sketchfab have problems. We can see right off here this bookshelf is embedded in the floor. Often you have to resize these and also fix their pivot. Artists have their own standards for how they size things. I'd like this bookshelf to be a little bigger, I think. So I'm going to scale this up. Let's try 1.5. That's maybe a little big. We'll go 1 1/4. So then the next thing we want to do is we want to open our modeling tools. One of the nice things about having modeling tools right in Unreal Engine, which are available in Unreal 5 and up, is that you can fix some of these things. This scaling I just did, I want to bake that into the model, and I also want to fix the pivot. We go into transform and we want to edit pivot, and we want it to be in the bottom, and we click accept, and then we want to bake transform and accept. So now that pivot, when we pull a new copy of this in, that's right on the bottom, that's aligned with our floor correctly, and it's the same size. So now when we pull this in through our PCG graph, it's going to be in the right orientation that we just set. So we want to do that with all our models as we bring them in. Some will be too big, some will be too small, some will have the pivot set correct, and some won't. You kind of need to go through all your models and do that, and I'm going to do that now. I like to create a materials folder. This is really materials and textures. I like to move all the materials and textures out of the folder where the static meshes are. It just makes things a little clearer. When you're sizing your items, you want to have them all the same orientation. So this bookshelf is facing away from us, so we're going to want to rotate that 180 so that it is facing toward us, just like the other bookshelf, and that'll help us out. And you can bake that transform the same way. It'll bake the rotation as well. Wow, this one's huge. That's one of the great things about items you get from artists on Sketchfab. You just don't know what the scale is going to be. If you're having a hard time figuring out what the scale should be, it's a good idea to pull in Manny, and then you can see if you've got that scale correct. I think that's about right. Now we have a table. We got two different bookshelves, one that's empty and one that's full. We have a crystal ball, a little wizard book stand. We have an open book, and we have a stack of books. That'll be a good amount of props to create a library or a wizard study or something like that. So we'll work with that for now. Sometimes when you're importing meshes from Sketchfab, you don't want to combine static meshes. For example, this elegant book pack, if I combined static meshes when I imported this pack, all the books would be combined into a single pack. So if I want to use these as individual books, then I wouldn't be able to. They'd all be combined kind of more like this is here. But with them not combined, you end up with this book separated from the pages of the book. So if we look at this, you can see that it doesn't have the pages in there. So the way you fix this is to select both these static meshes, bring them in at the same time. Then in your modeling mode, you want to go to transform again and merge. Accept that, and then fix your transform. Accept that, bake the transform, accept. And now you see it created this combined two. Combined was one I already did. And we can click here, and it's going to take us over to our generated tab, and you can see that new combined mesh, and we can rename this. And then we have that as a combined static mesh with both the book and the pages. So when we bring that in, it'll be correct every time. And we can have those single books done the same way. When you're moving your materials and textures out of your props folder, there's a quick way to do that. Click this filter right here and select textures or just materials. And then if you select all those textures and then you unselect that, those textures will remain selected. And then you can drag them into your materials folder and then repeat that for the materials. Now I've got all these books combined and renamed in my combined folder, and I want to move those back over into I've created a books pack folder under my props. Before I do that though, these original static meshes are no longer necessary. We can select all these and delete them. The new combined static meshes don't depend on them, so it'll be fine. And then we can move all these renamed books back in there. And then we have a nice bunch of static meshes that we can work with for creating individual books or having groups of books on shelves that look really nice and are easy to work with. When you do a bunch of edits like that, it's always a good idea to frequently do a save all. Unreal Engine does occasionally crash. So now we want to set up our room types. And I think it's always a good idea when you're doing data tables to not fill out a ton of rows before you really settle on your setup here, because I think we're actually going to end up changing the type of the room type here. When we go into our BP room, what we really want is an easy way to select what type of room this is. Doing this by name here means we have to type this exactly the same every time we use this, which is fine, but if you mistype something, and that is a source for error, and it's always best to not have sources of error. So let's set up another enumeration for our room types as well. So then in that, we can add our library, and you can add whatever other room types you want there. We'll probably add some more in a little bit here. Then we can go back to our structure and change this to room type. Save that, and then we can go to our data table and we'll select that as library. And then when we go into our BP room, we want to add a variable here, which is going to be our room type. And that's the type for this specific room. And that's also going to be room type. And we'll make that visible. We'll also make it exposed on spawn, which will be useful later, or might be useful later anyway. Then when we have a room here, we have our room type here. So we can select what type of room that is right here. And it's just an easy drop down, which is nice. For the next step, we need to get our room types into the PCG graph and then access our data table so that we can get the data and determine what types of props to spawn into our regions. So for that, we're going to create a new blueprint, and this is a new type of blueprint. We want a blueprint function in our PCG, and to create a PCG blueprint function, we come in here to all classes and search for PCG, and we want PCG blueprint element. And we're going to call this PCG BP room props. And then let's also rename this structure while we're here, because this is really more than just room types. This is room data. So let's name that room data. And then let's go into this room props function. So these PCG blueprint functions have some special functionality built in. And we're going to use this function execute with context. And we're going to build our function in here. And this is set up so that we can get the PCG functions using this context and this input here. We're going to use this context in a bit. Let's promote this to a local variable. Call this context. That's easier to get. We want to get our data table here first. And we get the data table. There's two pieces to the data table. We get the data table row names first. This gives us the names of all the rows in our data table. We want to select our data table asset here, which is DT rooms. And then we're going to loop through those row names, and we're going to get the data for each row. So these are now our row names, and we're going to use get data table row using those row names. And we want to select our data table asset here as well. So now we have this row, which is our data from our data table. So this is our definition of all of our data about rooms. And we want to match this data to our region and our room type. So we have our region here, our room type here, which should actually be named room type instead of room. Let's go ahead and fix that. That'll make that a little more clear. So we have our room type here and our region. And we're going to match those with this specific room that we're currently iterating for. In our PCG graph, PCG room here, we're going to be in these sections here, so next to room, and this is for a specific room. So we need to know what room type we're looking at and what region. So this is next to wall. So in order to have the regions here, we need a variable that's going to pass in that enumeration for next to wall. The way we're going to do that is we're going to go into graph settings, and we're going to create a new parameter here. And this property type, we want region. And now we can select the correct region, and we can name that to next to wall. And now we can get that property here, and this has the static value of next to wall set. And so we're going to want to do that for our on the wall points, our next to wall points, and our center points, which we haven't really set up yet. Our center points, we're going to come from here. This is actually our center here. Earlier I had said it's here, but this is the centers of our walls. Our actual center is here, and we're going to need a transform from that, and then we can create a comment here of from center. I'll set my color here. And then back over here to next to wall, we have this next to wall parameter. We also need our property from the blueprint, get actor property, and this property is our room type. And we can rename this so that it's room type. We're going to pass these two in to our new function. And the way we do that is really easy, actually. So we're going to just create a new variable here of room type, type of E room type. And we're going to expose that, and we'll expose on spawn. And same with region, and that's E region. And expose on spawn. And for this new function here, we want to go into our class defaults, and we want to expose this to library. And we can give this a category so it's easier to find. Let's call it meshes. And then when we go back into our PCG graph over here, we can see under meshes, we have our, well, that's kind of an ugly name. Let's fix that too. In our override functions, there is a function for the name, node title override, and we can give this a better looking title here. Let's call it region props. So now when we look at our PCG graph, well, it doesn't change it here, interesting, but it will change it here. So we see region props now, and when we open this up, we should have our room type and our region and our in for our points. So we can bring those in, and of course this doesn't do anything yet, and now we have that hooked up, and go back into our function and back into our execute with context. Now we have our room type and we have our region, and we can match those here. So we want, when these are equal enum, and we want when they're both equal, so we're going to and then we're going to want a branch, which we can get with B. When row is found and those are both true, then we're going to add that to a new array. So we want to create an array for those. Now since we're going to get all the data, let's call that room prop data, and that type is going to be our S room data. And that we want to make an array. You can actually right click to change that into array. And we want to get that, and then we want to add. Here on our true, we're going to add to this. And we're going to use this out row here. So we have all these items here in that array. And then we also want a max index. And that max index will be an integer, and that'll just make it easier for us to have the maximum value when we use that later. We're not returning here, we're going to return down here. So after our loop is completed, we're going to need another branch, and here we're going to check that max index, make sure we have values. So for greater than 0, we're going to do this functionality down here, and what we want to do down here is we want to get the input. The way the inputs work from the PCG graph is they're all packed together, so we need to use this function get typed input by pin label, and we're going to do that on true, and the pin label is just in. Our data class here is PCG point data, because we want the points coming into this function so that we can manipulate those points into our output. So we'll iterate through this with for each, and then we're going to send that data into a point loop, which is a special PCG function. And that point loop wants that context, which we set to a variable earlier. Put that in there. Compile and save this so we don't lose our work. For our point loop, we want to go into another override function, which is point loop body. And let's give ourselves some space to work here. So in here, we're going to want to add the mesh, that is our prop, to our point data. First, we're going to want to add the attribute to our point data because it doesn't currently have a mesh attribute, and that's going to be a string attribute. And we're going to name that mesh. And then we're going to set that attribute. And to set that string attribute, we need the point and the metadata, and we need the value, and we also need this name. The attribute we want to set is mesh. and we need this values. This is where we want to get our random prop out of our data. To do a random value, we want to do it the PCG way. So we want to use the PCG seed, break this point, and inside this point we have the seed, and then we can make a random stream, and from that random stream then we can get a value, and we want an int value. So make a random integer from stream, and our max value then is our room prop max index, and this is our random prop. So then we want to get that data from here, and we'll get a copy, and we want to break that. And then from our prop, we want to get the path with object path string. This is our path of our mesh, and then we pass that into this string here. And then our out point is also our endpoint. Clean this up a little bit. So now we have added our random prop to our set of points and output that new set of points with the prop in as mesh. So we'll be able to spawn static meshes this way. We'll have to do this different for other prop types, but for static meshes this will work perfectly. We need to make sure we check this return value, and let's save that. So now we want to go back into our execute with context, and our out data here is points. We need to pack that back into our context, basically. So we would need to make this into PCG tagged data, and then we need to make that into a PCG data collection. And that wants an array. If we just drag this into there, it'll make an array for us. And then that is our output type to our return node, and that comes from here. So that is our full PCG function. And so now we want to go back over to our PCG. We have that here, and we can take that output here and spawn in those props with the static mesh spawner. We can get rid of this filter points by going back into our PCG function, and over in our class defaults, we add a custom output pin. We'll make that out points, set this type to point, and then we deactivate this default output pin. Make sure our output is hooked up there. Compile and save. And when we go back over here, we'll get rid of this. Now we have out points, and we can see that's a point type, and hook that up. And we should really do that with our inputs as well. This is an any data type, and we really want it to be a point data type. So let's go back to our inputs here as well, and let's add in points and make that point type, and then get rid of our has default as well. Compile and save. So I forgot to change this pin label. And this is one thing I really don't like, string named values, because it causes problems. If we had just linked to this pin label, but we can't, that wouldn't have happened. This needs to be in points, which matches our name. And now go back here and rehook this up. And now we have points to points, which will make everything happier. And then we'll just clean this up a little bit. And now we should see next to wall, in our library room type, we should see those props spawned in. So, but of course we have to make sure we select in our static mesh spawner the correct setting here. We want the mesh by attribute, and the attribute is our mesh attribute that we set. So one issue is here in our prop max index, we want to add 1 to that. Because if we only have one prop in the data table, this is going to have a value of 0 because the index is 0. We actually want it to be 1. So the max index needs to just be 1 larger. And then that gives us a correct value here so that we get through this if we only have one prop. Then, there we go. And we've got our first set of props spawning in here in all these rooms, which is not what we want, but the default is 0, so that's the library, and so all the rooms currently are set to that because it's the only possible value. Still set up the other regions of our rooms before we move on to other areas. So let's go ahead and do that. Pop over here to our PCG room, and we can simply copy this without the self-pruning node and paste it here and down here. I'll start on the on-wall points first, and we want to replace this parameter here with on the wall. Did we not set that up? Oh, I guess we haven't set that up yet. Let's do that. It's going to be E-region on wall. Let's also do the center. Let's name this. And E-region. From center, rename from center. All right, now we can get that here. Plug that into our region, and then over here at the center, same thing. So now that those regions exist, let's go to our data table and add some props, DT rooms, and we'll add to our library. Let's see, we've got this nice wizard table and this book stand and the crystal ball. All of these are good center items, not really the open book so much. That'd be better on something. I'm going to add these to the center of the room, and then we don't have anything for on the wall, so we'll need to bring some more props in. And then I'm going to add some paintings to the props. So we have some items on the walls, find those. I'm setting the pivot for these into the center. Now I have some paintings that we can use. They're not the greatest fit for this project, but they'll work for prototyping, and that's really all we're doing here. So back to DT rooms, and we'll set in those. So now we have our on the wall items, and we have from the center items, and we have our original two next to the wall items. So let's go ahead and get those working. Right now we're not seeing them. So the first step here is to force a regen. So here we are. Our paintings are coming in, but they are embedded in the wall sideways, and they're at the same places as all of our bookcases. So we have a couple of problems here. One is that our bookcases are taking every possible spot, and so are our paintings. So we'll want to reduce the number of spots and make those work together so that they're both canceling each other. And in the center, we only have one item, which is working, but we want more items than that, so we have to change our number of points here from the center. Let's go back into our PCG graph. So the easiest way that we have to add points in this case is with a point grid. So let's create a points grid. And this points grid, we want to open that up, and we're going to set this extent. This is the size of the grid. So for that, we created a points grid here earlier for our floor. So this point grid is the size of our room, and that's what we want here as well. So let's copy this attribute down to the grid extent. Then we want to copy these points. Copy points. And this point grid is a new point grid. It's going to be our source, and our target is this center here. Let's just move that over, and then we'll run that into the transform. We need to uncheck this box here, cull points outside of volume, because we're not inside of volume when we're spawning this. So we need to make sure that's unchecked. So now we have points created by the points grid. They are copied over, and they're in our transform points. So let's turn debugging on by pressing D here. And I'm looking at this with the inspect, which you can get with A down here, and then you need to make sure you select which room you're in, and then you have to select data in or out, and sometimes you have to select something here to make sure this all shows up. So let's go back to the map and look at, ooh, lots of points. Wow, that's beautiful. All right, so the point grid is obviously very rigid, and we want a more organic spread to this. So we're going to change that. Well, one thing we can do, let's try this cell size in here as well. Let's see if that looks a little better. Yeah, then we're a little more spread out, and we have less points that we need to cull. I think that's a better starting point. And now let's add some randomness to this. We can just play with these values until they're more to our liking. So I'm going to set minus 200 in the X and Y as the min, and then 200 as the max. And then we'll set some rotation values. We want to rotate around the Z. There we go. And now that's looking more random. And obviously you can play with those values to get them scattered more the way you want to. And now obviously we have some points going outside of our room. So we'll need to fix those, and we need to get rid of some points. Let's turn the extents on. The extents is on. So obviously our points are very, very small. So we're going to need these points to be more representative to the size of our objects. At this point, we'll just set an extent around the point, kind of a spawn region, and then work with that for now. So just move that over, and then we'll use an extents modifier. And we'll set that extent to something like 200 by 200 by 50. And then let's move our debug over to that one. We're looking at extents, and we've got the cube on. Oh, it is showing to us in the wrong room. What room is this? Oh, this is room 0, and we're in room 12. So let's go here. Okay, so those are obviously too large. Let's try 100, 100. Yeah, that's a little more reasonable. And then let's add a self-pruning and get rid of some of those points. Okay, that's starting to look reasonable. Obviously, we have too many of the same things in here. Depending on what you're looking to design, this idea for a mage's study is probably better for a small room. And you can see here, the number of items spawned is much more reasonable. Well, it looks a bit better. It's maybe a little spread out, actually, since once we cut these edge points out, so we're not going through the walls, we're really only getting one item in here. So maybe we change that cell size to be a little smaller. We are running that into a half here. Let's use the half cell size instead of the full. That looks a little more reasonable. And then let's use our wall points to get rid of these items that are colliding with the walls. So we'll need a difference. And we want to subtract out our wall points, which are here. We are still getting this coming outside the room, so maybe for our extent we need to modify this grid extent. Where that's coming from is up here, this make vector attribute, and if we look at that is this size here. So if we just do some math here, we take this and we're just going to want to subtract another vector off of that. So we can subtract off a vector here. We'll make a new vector to subtract off of this previous vector, and then to make a constant value here, we'll use add attribute. We'll make this 100, and then we'll just duplicate it. So we'll just subtract off 100 by 100 from that previous extents, and that'll be our new extent. And now it's just a little smaller, and all those spawns are inside the room. And if that's not enough, you can just adjust those constants here to make sure that all fits inside the room. And if you want to increase the density of this, you can just play with the cell size, this extent here, in order to spawn more or less items into this room. So for our points over here, we currently are not using an extent. So let's get an extent in here as well. With this self-pruning, that was just getting rid of the corners, but we may play around with this a little bit. With this transform points, we can move these shelves around and make it a little more organic. If we set these X and Y to minus 100, 100, now our shelves are going to be not exactly placed, and we get some colliding here. And then if we get our extent in here correct, let's set an extent. Then this self-pruning will take care of those colliding nodes, and we'll just have a little more space. Let's just set the extent, and let's make this 100 by 200 by like 200. And let's debug that. What room is this? This is 8. Select 8 here. We've got our debugging over here, and we're seeing the debugging for the center still as well. Let's turn that back off. Can just look at this, and we want our extent to be the size of the bookshelf or whatever you're spawning in there. So let's modify that. Getting closer, but it's the wrong direction. That's close to the correct size. So now that looks about right. We do have one issue here with our doorway. We'll address that in a minute. So let's turn this debugging off. And let's address these facing the wrong direction. Down here, transform these points. We're going to rotate these by 90. And our wall does have a thickness, so I think they're inside the wall. So let's offset them a little. All right, so there are the paintings. They look good, a little too uniform. So we can also, in our transform points, we could adjust the scale. And then we'd have some variance in our scale. That's kind of interesting. So we also need to get an extent going for these. It's probably a very small point. Let's just set it with an extents modifier. Let's also create some random variation. Oh, so because these are, see how these are aligning at the same spots? It's because we're starting with the same set of points, and then we just transform them in the same directions. We end up with the same points. So they're going to cancel each other out, which is not good. Or if we just invert this. You know, that works pretty well. Yeah, let's just go with that. And then let's get this extent going here. It certainly covers them. So now, before we spawn those in, we can add a difference. And we're going to subtract these points. Debug those now. Oh, on our difference, we want this to be binary. There we go. And that looks like we have 2 there. So let's also put in a self-pruning. Turn this debug off. Yeah. Now we're getting somewhere here. We obviously need some more variety, but that's easy to add. We just add more items to the data table. We need to subtract our door points out from both of those. Let's get our door points. That's this here. This goes into differences. Okay, there we go. Do that up here as well. All right, yeah, and that gets rid of those. Okay, so the next thing I'd like to do is maybe I want some props to be more prevalent than others. Like in this case, I don't think I want that many desks. I don't have a prop in there that I'd like this many times, but let's just say you did, and you want something more prevalent and you want some things less prevalent. We want to do a weighted random instead of just a random. So let's go back in our PCG room props and into our point loop body, which is what came up for me, but you want to be in point loop body in this random stream here, and we're going to modify this so that we have a weighted random. And we'll need to add a weight here. Let's go back into our structure for that first. SRoom data, and let's add a weight. It's probably just easier if we make it an integer. You can do this a variety of different ways depending on how you want to do the math, but it's a weight, so whatever weight it is, we don't have to do it from 0 to 100 or 0 to 1 or whatever. It can be whatever values. The higher the value, the more likely it is that an object will appear, and the lower the value, the less likely it is to appear. So if you make it from 0 to 1,000 and you make, one item 800 and one item 1, that one item is barely ever going to show up. But if you make it from 0 to 100, one item's 45 and one item's 35, they're going to be fairly even distribution. We'll go into room props. We'll add a weight for some of these. The easiest probably to start with is the bookshelf. Let's do 85 for these, and let's do 20 for this bookshelf. Here in PCG room props, we want to find our weight right here. We need to go out to execute with context because we need a sum of all the weights, and we're already looping through the room data. So we can use this to give us a sum of the weights. So let's add a new variable here, sum of weights. We can make that an integer. We need to get that and set that. So we're going to get that. We're going to add this new weight to it, and that'll be the new sum. And to be certain, when we start this function, let's set sum of weights to 0. It's always a good practice. So now we should have sum of weights, except hold on, this is actually in the wrong spot. We want to sum the weights for only the values that we're using which is after the true. We need to move that to there because we want this to be for this room, this region. Move this back. Let's put sum of weights here. And now compile and save. Back over to our point loop body. And here, instead of getting random prop index max value, we're going to use sum of weights. So we're going to get a random value between 0 and our maximum weight. Obviously, we can't just use that as the index, but what we are going to do is we're going to create a loop here, and we want to loop over all these. Okay, so let's get rid of this get, and then we will loop through each of these, and we'll need to do this before this set string attribute, after adding the string attribute. So we'll loop through each of these props for our current room, and then we're splitting this here. Actually, we can just split this right in this loop. We want this weight right here, and we need to save this random weight that we just created. Let's add a variable random weight, set that, and then inside this loop, we're going to take this random weight, we'll get it, and we're going to subtract our current weight for this item, and if that weight is less than 0, then this is the item we're going to spawn in. So we'll do a branch here, and on true we're done. So actually let's make this a for each with break. Move all this down. So on true we're going to break, and then on false we'll set the random weight to be this value. Because we're decrementing through this random weight until we get below 0. So what this does is when an object has a high value, it's more likely to cross below 0. And when it has a low value, it's less likely unless we've created a low random weight. Higher weighted objects are going to spawn more frequently. But because we constantly subtract from this random weight, we're always guaranteed to spawn something. So on completed here, then we'll go back up here and we'll clean this up in a second here. And then this is our object that we're spawning. All right. So let's clean that up. But I think that looks all right, and let's give this a try. So based on what I said earlier, we should be seeing a difference here. Yeah, where we're seeing a lot more of these large bookcases and less of these. And let's make that more exaggerated. Let's set this up to 150, and then we'll set the other one to 5. Now we're going to need to force regen, and then yeah, we rarely see these, but look, in a room full of these, we see 3, and so I think that's working correctly. So now we can adjust the weight of these different paintings, we can adjust the weight of the desks, you know, whatever we need to, so that we get an even distribution. And actually this has created a problem. So we need to make sure we set a value, because now we're getting only desks. So all the desks have a weighted value of 0, and so it's all desks. So we need to make sure we go into here and set a value for each of these, or you're just going to get one thing. Okay, and make sure you hit force regen after you do that so you can see the changes. Another thing I did here, because we have this weighted now, we can actually have a no value. So to my on wall, I added a none and I gave it a 45, and that gives a chance of just blank sections on the wall, which, considering the short number of props we have here, I thought that might make it look a little more realistic, have some empty spots, and not have everything filled. And I think I'm going to do the same thing right now for bookshelves as well, because I don't really have enough next to wall props here either. And make sure after you change those, you do a force regen on your PCG so you can see what those changes look like. Now that looks a little more organic, though truly this needs more props to look properly organic, but you can do that on your own. I noticed while I was looking at this that we have a couple of bookcases coming through the walls. Let's fix that. So I've turned on the debugging for the wall points. That wall point should intersect with this, but I think our wall points actually stick through the walls. I think they're going to intersect with our other bookcases as well. So we're going to have to play with the extent a little bit to get these subtracted and not these. So let's go back into our PCG room. Let's take this set steepness here and let's set the steepness on this. And then let's take a look at our points there for that. Okay, then let's subtract out these wall points, but we're going to need to make them skinnier. So take this into an extents modifier where they go into the difference. And let's take a look at debugging this extent. What are we seeing? Oh, we set it to 111. Okay, that's no good. Let's copy this guy. We'll use that modifier and we'll just reset the values. So instead of 10, let's just go 1 here and 1 and see if that gets us where we want to be. Debug. And those are very skinny, but they're still hitting all the points. There's not much intersection between them, but I guess it's enough. I'll probably just make this skinnier. Yeah, I did the trick. So I just modified this one on the next wall to be 20 instead of 25. And those are still blocking pictures. Turn that debug off. So you can see that there's no pictures appearing behind them, but we're not getting them going through the wall anymore. Thinking forward of what else we might need for this, I realized that it would be nice to have a limit on the number of props spawned in a room. For example, if we want a unique prop that is guaranteed to spawn. So let's go ahead and set that up as well. So to do that, we're going to go into our structure again as room data, and we'll add a max spawns and also add a total spawned. And we'll make those both integers. So the max spawns we're going to set in GT rooms, and the current spawns we're going to leave empty. We'll use that just in the structure, not in the data table, so that we can store the number of props that we've spawned. I'm going to go in here and I'm going to use this table as a good example, and let's set that to only spawn 1. If we set total spawns as 0, we'll treat that as unlimited, and then if there's a value set, then we'll limit that. So then let's go back into our function PCG blueprint, and in our weights we'll track how many we have spawned, max spawns and total spawned here. When we spawn 1, so when we're completed, we get our object, and that's what we're spawning. When we are spawning, we want to increment array element total spawned. So let's move all this over so we have some more room to work here. Since we're wanting to write this back into this large array type, we're going to need to write all the values that stay the same, as well as this value that we're incrementing, the total spawns. Let's add 1 to the total spawns, and then we're going to use set array element. And that target array is this array, and then we can break the item, and we can set all these the same, except for our total spawns. And for our total spawns, we'll take it off this increment +1, and then we can move this to here so that we're doing that on our completed loop, and we'll try and keep this clean, which gets a bit tricky here. Then we want to check this total spawns against our maximum spawns. So if our maximum spawns is equal to 0, we're going to let this go through as normal. But if it's not equal to 0, so on the false, we're going to check it to see if it's greater than our total spawns from our max spawns versus our total spawns. And then that's going to go to another branch. If that's true, then we're also going to go up here to this branch and spawn that. So now, because the loop could end here on either of these true branches and come back around here and break, or it could potentially end here on the false where it doesn't spawn something in, we need to check down here whether we spawned or not. So what we need here is a new local variable, spawned, and we'll set spawned here on this top part of this loop, break this right here, and we'll run this into spawn and set that to true here. And then just to be safe, let's set that to false back here. Actually reset this in the loop body, set this to false. And then down here, before we set this array element, we want to make sure we do that only when we're spawning. So let's check that. We'll need a branch, get spawned. This is really difficult to make neat. Let's try moving all this over a little bit more here up the top. And maybe we'll move this stuff down a little bit. That's probably about the best we can do here. When we come in here, we're looping through just like normal. If the value is 0, we'll do this random wait just like we did before. So we'll spawn in an infinite number of the prop. But if the maximum spawns is not 0, then we will check against our total spawns. We want to check against total spawns right here, not against the add one of total spawns. We can take this here and connect it that way. It's a little neater. So if our maximum spawns is greater than our total spawns, then we will spawn in an element and add one to the element array. So that should be good to go. In DT rooms, I have the wizard table set to only spawn 1. Let's take a look at our room here. And we are getting 5. Here's the issue. When I set the element array, somehow I missed the index. That's very important. We need to set the correct index. And now, there we go. Now we only get 1 table. And that's all there is to that. So now I'm going to clean up a couple of props. I see these are sitting a little low. I might bring in a few more props. Definitely I'm going to bring in more props before I use this for anything. And then I'm going to set up another room. Probably quickly show you setting up another room, and then we'll call this session done. Discovered that some of the points were spawning in below the floor. These books, it was noticeable that they were lower down than the others. And the reason for this was because when I use these center points here, they're the same target as we used for the original floor, but this floor extent goes from -5z to 5z, which means when we copy these points onto the target from the center point, it needs to be raised up. I found that if I added a transform point here off the center and added 10 in the z direction, that those books now appear correctly on the floor, as do the other props. The next to wall points actually have the same issue that the center points did, where props are spawning below the floor because we started those points from the wall points. So they just need to be raised up a little bit, and that can be done right here by modifying this transform points and just setting this Z at 10 on both the min and max. Never noticed it before because the bookshelves being embedded in the floor doesn't really look any different, but now that they're raised up, you can see that they display properly actually. So it's just more noticeable when I put in these suits of armor. You can see this banner here is going through the wall. I'm going to fix that the same way I fixed the next to the wall problem with the same sort. Take this bounds modifier and put it into this difference as well. But the problem with that solution is that these aren't going to touch. So look at that. We'll see the box is here, and what we're matching against is way down here. So we're going to need to modify this bounds vertically, and that took care of it. You need to make sure that you set a weight. If there's a 0 weight, it's not going to put any of the prop with a 0 weight in. So you have to make sure you set something now. Thank you for watching part 2 in my PCG Interiors series. If you found this helpful, please make sure to like the episode to help the video out. While creating this video, I realized I can expand on this topic further. So in the next couple of episodes, I'm going to work on adding PCG subgraphs so that we can create tables, shelves, weapon racks, etc. with random items on them, as well as including active blueprint objects like torches and lit candles to our rooms. We're also going to work on spawning our rooms in randomly with a parent PCG graph that will allow us to connect our rooms together and create random room layouts. So make sure you subscribe so you won't miss the upcoming episodes. If you'd like access to the future episodes early, or you'd like to get copies of the project files from this project, you can join my Patreon, where I'll be posting future episodes before they reach YouTube. If you need assistance with this project, please join my growing community Discord. All the links are in the description. I look forward to seeing you in the next episode.